Do you ever lay in bed at night and as you're drifting off to sleep, you start thinking about insulating mobile home underbellies, and then you think, man, I wish I had some sort of an attachment that I could screw to my insulation test box that would simulate a mobile home underbelly. That'd be awesome. Well, me too. So let's build one today. All right, so I'll kind of run you through my thought process here. When you're insulating mobile home underbellies, it's different than dense packing cellulose and walls. You're using a different material. You're insulating it to a different pounds per cubic foot, which is pretty low in terms of dense packing. So when you take guys that have always done cellulose and you turn them loose on an underbelly, a lot of times you're going to run through way too much insulation. It can really set you up for disaster. Underbellies are also unique in that you can actually feel what's happening in that cavity through the underbelly, and if you can flick it and it sounds like a snare drum, you've probably got too much insulation in there. So I thought we'd build an attachment that could screw onto the face of a test box that we can calculate the volume of it, we can fill it full of fiberglass, and then kind of see, feel what it feels like. The guys can get a good sense of what the tactile part of insulating mobile home underbellies is. So my plan is, and we'll see what we do here, I'm going to take this sheet of plywood. This is 2x4, the same size as our test box. I'm going to cut out everything but 1.5 inch perimeter. I'm going to stack this foam underneath of it that I can easily calculate the volume of, right? That's pretty simple to do. I'm going to wrap it in a blue tarp and then screw the tarp to the underside of this, and then take this back out and you'll have what would be in sense a mobile home underbelly. So let's get to cutting all these parts and pieces, and we'll go from there. All right, so let's go over our math here. On sheet 1, which would be our solid sheet of foam, on the inside of that test box, that's a 2x4 test box on the outside, so we've got to take off for our framing on the inside. So that's 1.5 inches all the way around, or 3 inches off each way. So we ended up with 21 inches by 45 inches by 2 inches for the thickness of the sheet. That gives us 1890 cubic inches. We divide that by 1728, which is how many cubic inches are in a cubic foot, and that gives us a total of 1.9 cubic feet for the top layer of that we wrap that tarp around. For sheet number 2, we started with the same 1.9 cubic feet as the top sheet, but we've got to deduct, remember I cut an angle all the way around that bottom sheet on the sides at a 45 degree, so we need to deduct 0.15 cubic feet for that, and that gives us 0.94 cubic feet for that sheet. Now we need to figure the volume of our frame. That frame is 21 inches by 45 inches by 1.5 inches deep. That gives us 1,417.5 cubic inches. Again, we divide that by 1728, which is our cubic footage, or square inches in a cubic foot. Cubic inches in a cubic foot, and that gives us 0.82 cubic feet. So now we want to add all these measurements up together to give us the thickness of our frame, our top sheet, and the sheet we cut bevels on for the bottom. So when we add all those up, our top sheet, our second sheet, and our frame, we come up with 2.85 cubic feet for this little underbelly prop that we've made. Now we need to add that to our test box. Now commonly when you build a test box, it's going to be 2x4 on the outside, 2 foot by 4 foot, And the only thing that really changes is, excuse me, the material you make it out of. So it might be 3.5 inches or it might be 5.5 inches. So 2x4 or 2x6. So if you've got a 2x4 test box, 2x4 by 3.5, let's say, it's 1.91 cubic feet. If you've got a 2x6 test box, it's 3 cubic feet. We use a 2x6 test box because that 3 cubic feet is just pretty easy to calculate. When you're running test boxes, you tend to run a lot of them getting your machine set up. So it's just easier math sometimes. I mean, you're doing it with a calculator anyway, but it's just kind of simple. So what we want to do is, again, we got to add up all these volumes. So if we're on our 2x6 test box that we currently have, we would add 2.85 to 3. We'd end up with 5.85 cubic feet. Then we would take that cubic footage and multiply it by whatever material we're using, which would be fiberglass. We don't ever dense pack underbellies with cellulose. So we know that, I don't want to quote this off the top of my head, I think it's 1.5 pounds per cubic feet we do fiberglass at. So that's what we'd multiply it by. So anyway, I'm going to trim this out a little bit, and we'll put it all together and put it on the test box, and we'll see what it looks like. All right, so I want to just take a second to kind of go over our test box here. Normally, as it exists, you know, when we built this, we always figured on having a wall panel on it. So when we're setting it up for doing walls or anything, we figured the original weight with that wall panel on it. We've made some notes on ours. Let's see if I can show them to you here. This box is 3 cubic feet on the inside. So if for any reason we need to do some other calculations, it's written in stone what this is. Empty, this box weighs 47.37 pounds. When it's full of fiberglass, again, we're shooting at 1.5 pounds of fiberglass per cubic foot of underbelly when we insulate them. So when this box is full of 1.5 pounds of fiberglass per cubic foot, it should weigh 51.9 pounds. When this box is full of cellulose at 3.5 pounds per cubic feet, it should weigh 57.9 pounds. One thing I'm always kind of on the fence about with this, we wrote the empty weight on here. We've got a really high-end scale we use for weighing refrigerants. It's always been that weight every time we've tested it. If you're doing this and you've got, you know, a lesser quality scale, that scale may not always say the same weight every time. So it's probably honestly better practice. We do it anyway, but maybe not to have your empty weight on there, and just, you know, do all your calculations on a piece of paper, and don't, you know, we always verify it, so it's not that big a deal to us, but it may not be what works for you and your equipment. Okay, so we got our prototype underbelly test box simulator 2000 all rigged up, ready to go. Again, if we built this out of scrap we had over here at the IWAP West wood shop, so just basic construction goods, but we've made, if everything works right, slides off. Got your regular box there. That should just, you know, we know the volume of this now. If you want to run a test, really just put that over it. Like a glove. Fill it up, and when you get it full, it's a good way to give your crews a little bit of a, you know, they can feel this. They can get their hands on it. That's the nice thing about doing underbellies, is it really is the only insulation dense packing method where you can get your hands on it and kind of get a sense for it. But yeah, we'll fill it up. We got a dense pack clinic coming up. We'll fill it up and see how it goes. And if we like it, we'll make a nicer one maybe. If we don't, we'll throw it on the burn pile and call it a day. All right, see you guys.